Okay, so in section 8.1, you're looking at solving systems of equations. That just means you have two equations and two variables that you need to solve for. And in 8.1, you're doing this by graphing the two lines and then looking for the point of intersection. So I put several examples for you in the notes. I'm referencing one of those here. Now, the examples that I worked for you in the notes, I actually went through how to get the graph. I did that using the slope-intercept form, which is something that you should be familiar with. But just to remind you, if you solve the equation for y, you will find the y-intercept as the constant term, the term with no variable, and so you can plot where the graph crosses the y-axis. So you'll notice my first line, it was at -10, that's the purple line. My second line, it was at -6, that's the green line. And then just remember that slope, which is the coefficient of the x, slope is always rise over run. So it tells you how far you can go up or down on top and how far you can go left or right on the bottom. Now, when you're working these problems in Hawks, it will actually do all the graphing for you. So when you're doing your homework in section 8.1, all you're really going to have to worry about is solving it for y and then looking for the point of intersection. All right, so let's take this particular problem just for example and look at how I would work through this in Hawks. Notice it asked me to solve for y in each equation because that will give me the slope-intercept form. So if I do that first, I have -4x plus y is equal to 10. Now again, to get slope-intercept form, it just means I have to solve for y. So if I wanted to get y by itself here, I would add 4x to both sides. And this equation would become y equals 4x plus 10. Now again, that's a y-intercept of 10 and a slope of 4. But if I come back over here to Hawks and I go ahead and put in my slope-intercept form, right, 4x, x is already there, plus 10, then you'll notice the graph is already constructed for me with a y-intercept of 10 and a slope of 4. So if I do the same thing with the second line, -10x plus 2y equals 22. Slope-intercept form, again, I want to get y by itself, so I would start by adding 10x to both sides. This will become 2y is equal to 10x plus 22. And then to get y by itself now, I've got to divide by 2, and that means I have to divide everything by 2, right? All terms have to have the same thing happening to them. So this equation would become y equals 5x plus 11. So again, this one will have a y-intercept of 11 and a slope of 5. If I come back over here and I enter my slope-intercept form that I just found, then again, what you're going to notice is that it graphs the line for me with an intercept of 11 and a slope of 5. And then what I'm doing here is I'm looking for the point of intersection. Now, I'm going to try to zoom this one in so I can see a little bit better. But looking at my graph, it appears to me as though these two lines are intersecting when x is -1, right, 1 back from that y-axis, and when y is equal to 6. So I'm going to state that this has one solution when x is -1 and y is 6, because again, that is the point of intersection that I'm seeing in the two graphs. Now, keep in mind, you'll only have no solution when you graph the two lines and they are parallel, they run side by side, and have no point of intersection. And you will only have an infinite number of solutions when you solve for y and it turns out you have two identical lines where you're graphing the exact same line right over top of the other one.